ओके, काइनेटिक एनर्जी हम लोग डिस्कस कर रहे थे. तो okay, so we are going to discuss kinetic energy. So what is kinetic energy? So energy of a body is capacity of doing work. So that we have already defined the work. What is work? So how much work a body can do, that is called its energy. Okay, so that is the energy, or that is the capacity to do the work. Okay, so that is the thing which is known as energy. So if we have a car, so if a moving car, if you see a moving car, it is having kinetic energy. So why do we say that it is having kinetic energy? Even after stopping the engine, suppose you stop the engine and you just let this car go on by itself. So it can do some work. If suppose it is moving against the air drag and against the friction, so it will do some work against that friction. So it is able to do some work. Or if something comes in front of the car, so it will push that object, so it will do some work. So it has capacity to do work. That's why we say that it is having kinetic energy. A moving vehicle possesses energy since it does work against friction and air resistance before coming to rest after the engine is switched off. Okay, so even after engine is switched off, it can do some work on the other objects. Okay, second example, we can take water stored in a dam has energy since it can run the turbine when the water flows down the turbine. Okay, so if a water is stored in that in a tank, and if that water is allowed to flow from there, it can run the turbine and it can do some work on the turbine. So that's why we say that it is having energy. So in machines, or for mechanics, if we say we are interested in mechanical energy, so mechanical energy is what it is having. Then two parts. Mechanical energy is split into two parts. So whatever we are going to study in mechanics, whatever energy we will study, that is mechanical energy, and it is of two types. One is kinetic energy and second is potential energy. So kinetic energy is due to the motion of the object. Potential energy is due to configuration or position of the object. So these two things we are going to study in detail. This is kinetic energy is by virtue of motion, and potential energy is by virtue of position or configuration. Okay, first we will study kinetic energy. So kinetic energy is energy possessed by body by virtue of its motion. It is measured by maximum amount of work that can body do. Okay, so how do we calculate it? So a vehicle in motion, a satellite going around the earth, these are the examples of kinetic energy. A bullet fired from the gun, this is also example of having kinetic energy. A water flowing along a river, that is also having kinetic energy. So what is the expression for kinetic energy? So expression for kinetic energy is half mv square. Okay, so that we are going to derive. So a body of mass m is moving with velocity v. Suppose a body is moving with velocity v. A uniform force opposes the motion to bring the body to rest in a displacement s. The uniform acceleration of body due to force is a. So we are going to derive the expression for kinetic energy. So how do we derive it? So since a opposing force is acting, so can we write v square minus u square equal to 2as. So final velocity minus initial velocity equal to 2s. Okay, so final velocity is 0 and initial velocity is, suppose we write it as u only, not v. Or better we can do this. So this we can write as v dash. Okay, v dash. So there will be no confusion now. Okay, so final velocity square minus initial velocity square equal to 2s. So initial velocity is given v square, final is 0. Finally object is going to stop. finally, if object is opposed by some force, the object is going to stop. So if object stops, it will deliver all of its energy which is possessed by it as a work. Okay, so that we are going to find. So final velocity is what? 0. So what we will write is what acceleration we are getting. The acceleration which we are getting is minus v square by 2s. Okay, so the acceleration into mass, if you write, this is the force, this is the opposing force. The opposing force which we are getting is how much? F naught is minus v square by 2s. So if this is the opposing force, then as a Newton's third law, we can say that the force exerted by object will be negative of this value, negative of this F naught. Okay, so we can say that the force exerted by object will be what? Mv square by 2s. The force exerted by object is mv square by 2s. Okay, so this is the force. What? This is the force on the object, and now this is the force by the object. Okay, this lower one is force by the object. So force by the object we can write as mv square by 2s, and the work done, if we write by the object, we can write F into S. So work is F into S. So we can write mv square by 2s into S. So we can see that the work is coming, the maximum work is coming half mv square. After that, the object cannot do any work because the object has come to stop. So we have finally taken final velocity, we have taken as 0. So this much work can be done by the object. Okay, so in this way we can show that kinetic energy is the kinetic energy is half mv square. That is the maximum work which the object can do. So this was for constant force. This can also be shown for variable force. Okay, now we will see the relation between kinetic energy and linear momentum. When a body of mass m moves with velocity v, its linear momentum is mv, and kinetic energy is half mv square. So what we can write is v is p by m. V is p by m. So we can replace the value. We can replace the value of v from this one. Okay, so if you replace it, we are going to get this p square by m square. So p square by 2m. So this is the relation between kinetic energy and linear momentum. So if kinetic energy is more, linear momentum is also more, but the relation is in square. It is not direct linear relation. Or we can write p is under root me. Okay, so some points to note here is when a bullet is fired from the gun, the momentum of bullet and the gun are equal and opposite. From conservation of momentum, we can say this: the kinetic energy of two bodies having same magnitude of momenta are in inverse ratio of their masses. So how do we know that kinetic energy inverse ratio of the masses? We had written that p square by 2m. Okay. Momentum is same, then kinetic energy we can say that inversely proportional to mass. So for a bullet and gun system, if you consider bullet and gun system, bullet is having much smaller mass and gun is having larger mass. So larger mass means smaller kinetic energy. So gun is having smaller kinetic energy and bullet is having larger kinetic energy. So we can say that is inversely proportional. The kinetic energy inversely proportional to mass. So this kind of relation exists if the momentum is same for two objects. Okay, now we will see work energy theorem. So what is work energy theorem and its applications?